Hi, we are Group 5. I'm Lin Siyu. Our members are Lin Siyu, Li Kunhong. We had 4 members in this group originally, but only left for 2 members now. Our main topic is about time. The project name is The Time in Your Mood. With this model, you can have your own time. Let's see together. What is it? It's our model, The Time in Your Mood. This tool is about measuring time. Its frequency is changeable. It can give you a period of time and it can reflect your mood. Of course, our model is for everyone, so it is easy to operate. What does it do? The model can not only give you a period of time, but also reflect your mood. When you are in a hurry, its rushing sound can urge you. On the contrary, when you are not in a hurry, its sound will not be so rushing and it can relax you. We can also use this model to weigh things. Of course, you can have fun with it. Why we choose it? It was amazing when we first saw it. We want to understand how it works and feel that there is a lot of room for testing and development. We want to use its characteristics to find a way to use it. Explain the math. There are 2 aspects of our time. The first one is the physical time and the second one is the mental time. About physical time. This equation explains that when a displacement S is generated in the direction of the force, it raises the work. The key principle of this model is to use the ingenious design of the escapement lever to give the work done by the heavy object to the single pendulum through the gears. The pendulum in our model is also a switch. As we let simple pendulums start to swing at a small angle, the model starts to work through the mechanical device on the top here of the simple pendulum. The escapement lever will be pushed up, and the gear will start to move. The potential energy given by the heavy object will give the simple pendulum kinetic energy through the blue gear, and the simple pendulum will return to the previous position due to the conservation of mechanical energy. And the escapement will stop the gear at this time until the pendulum swings forward to it to push the escapement lever up to let the gear rotate again. What we find from our model. If the heavy object is heavier, the pulling force will be greater and the gear rotation will be faster. Now you will get a higher frequency of strikes of the escapement lever. This picture is from our Python simulation. Meanwhile, the item that pulls the gear will fall faster. Maybe you think it is logical after listening, but before the experiment, some people think that the frequency will be the same. I was nervous because I thought it should be different. I just felt it would be different, and based on this, I wanted to find the relevant data. After I did the experiments, it proved that there would be different frequencies with different weights. This thing tells me the experiment is important. If you can't figure it out, then experiment. Now I'm going to talk about the mental time. I believe that everyone knows Einstein's theory of relativity and has a feeling. When you are happy, you will feel that time flies very fast. When it's painful, you feel that the time passes very slowly. Also, when people are in a hurry, they feel that the ticking of time of the clock is particularly rapid, but when it is calm, the ticking of the clock is gentle. Therefore, a minute in the physical sense is not necessarily a minute in the heart.
Hi, I'm Kun Hong. I'm going to talk about Python simulation. We use Python to make animation to simulate this pattern. There are three different parts in our model, including pendulum, escapement lever, and gear, with heavy objects. Combining the different parts above is our model, as the picture shows. This is pendulum, and the pendulum in our model is also a switch. The model starts to work when we let the simple pendulum start swinging at a small angle. By means of a mechanism on the top of the pendulum, the lever is pushed upwards and the gears begin to move. This is escapement lever, and the escapement is used to stop the gear until the pendulum swings forward to push the lever up, causing the gear to spin again. Therefore, the escapement swings up and down. This is gear, and the potential energy given by the heavy object will be transmitted to the gear on the upper right through the intermediate gear, and the gear will finally give the simple swing kinetic energy. This is combination, and let's show you our Python simulation. The picture shows our final model, and we can see the relative position and relationship of the pendulum, gear, and escapement. We make each part of the Python simulation and combine it into a model, including gear, bracket, escapement, and pendulum. Our clock uses a heavy object to give a stable gravity to pull the gear. The correlation between the gear, the escapement lever, and the pendulum will make the escapement have a stable percussion frequency. The heavier the object, the greater the pulling force. The faster the gear rotates, the higher the strike frequency of the escapement lever will be, and the faster the item will fall. Our purpose of the experiment is to demonstrate that different weights have different frequency. Our experiment item involve that our model, scale, ruler, and the heavy object. Heavy objects include notebook, paper, and pencil case. The left picture is our experimental device. We add up heavy objects to the big gear and use different numbers of the notebooks to represent different weights. We choose one notebook, two notebooks, three notebooks, respectively. This is our measurement data toward different notebooks. It proves that there is a relationship between objects' weight and the frequency. The more notebooks there are, in other words, the heavier the weight, the faster the beat of the escapement lever, and the longer the rope used. We encountered some problem with our experiment. Notebooks of different brands will have different weights. Although there is a positive correlation between notebooks' weight and escapement lever stroke frequency and roll length, small weight differences can lead to great errors. Therefore, it is very important to keep the weight fixed, and errors cannot be caused by measurement. We need to improve the content of the experiment. Therefore, we later replace the notebook with paper. Each piece of A4 paper will have the same specification. After measurement, it is found that the error is very small. Since everyone can buy the same A4 paper, it is easier to use our data results without having to buy a scale. We assume a stack of paper is 10 sheets and conduct the experiment. By the way, the paper will be used as the unit because we hope our clock can be used simply. In order to get the weight data, we also go to the post office to use their scales. We don't think everyone has a sophisticated weighing instrument, and using paper is to make it easier for everyone to see and compare the weight. From the data in the scale, we can know that one stack is 51.2 grams and so on.
This is our data from our experiment, and it also proves that there's a relationship between objects' weights and the frequency. We not only know that they have a relationship, but also get the formula. So we can get every frequency to any weights and the rope length needed to any weights in 30 seconds. We used the model and our finding to measure time. Let's see how to apply. Just choose the number of stacks of the paper, that is the weight, based on the feeling mental time you need. Then choose the length of the rope to determine how long the time, physical time, you need. In this way, there is a time of one's own, both psychological and physical time. Example 1 about the application. If you want to stretch or do yoga and to maintain a posture for 2 minutes, you can use our model, the time in your mood. In this situation, you are not in a hurry and want to be relaxed, right? So, take 2.5 stacks, that is 25 sheets of the paper, to get a low frequency strike sound. From our data, if you want to get 2 minutes with 2.5 stacks of the paper, you have to set your rope length for 42 centimeters long. After setting, you will get 2 minutes with a relaxed sound. So, if you want to do yoga, use our model. You can have fun and have your own time. Example 2 about application. If you want to hold a drinking competition with your friends to see who can drink more in 30 seconds, you can use this model. Since the game is exciting and intense, you can choose 4 stacks paper, that is 40 sheets of the paper, to get a high frequency strike sound. Then choose the rope length of 11.2 centimeters to get 30 seconds. Now, you have a time for this situation in 30 seconds and an exciting feeling. This is another example of our application. If the weight of something, if something's weight is the same with a number of stacks of the paper, their data should be the same. So we can know that that thing's weight. For example, we chose a pencil case as heavy object and applied the data which is measured. In 30 seconds, the number of the strikes was 54 times and the rope length was 10.7 centimeters. This data is the same as 3 stacks, so we know that they have the same weight. You can see their weight is actually the same. So through the model and the data, we can get something's weight. There are 3 different situations. One is with 1 notebook. The second one is with 2 notebooks. The third one is with 3 notebooks. And they have different frequencies, slow, medium, quickly, respectively. So you will feel relaxed, feel no more, feel hurry with different situation. That is, the heavy object is with different weights. And let's show the practical realization video. Let us see is actually is really different. And with different weights, the frequency will be different. Let's see together. And in fact, there are some problems during the experiment and the measurement. For example, during the experiment, it was found that the weight of the heavy object should not be too heavy. Otherwise, it will be unstable, or you can see the gear was broken. The heavy object is too heavy, causing the gear to break. As the picture shows, it was sad, and therefore I had to buy a new one to replace the broken one. When I beautified this device, I wanted to choose buildings in Italy. I couldn't believe that I took the Arc de Triomphe. I know it is in Paris, in France, but I picked it. I thought it was funny. I couldn't figure it out what I thought then. So if you think it is weird why there are 2 Italy buildings and 1 French building, it was just a mistake. Since I didn't have a scale with a unit of grain, I took my notebooks to the post office to weigh, and then found the error mentioned above. So I needed to go to the post office again. Later, I borrowed one from others. As a result, I realized that not everyone has a scale, even a scale with a unit of grain. So I use paper as heavy objects so that everyone can use our data. The problem about the measurement. Measuring is simple, but getting accurate measurements is difficult. Because the length difference is small, there is easy to get many errors in the measurement at the beginning, and I tried to measure in many ways to improve it. Finally, a simple explanation. First, set a starting point outside the device, then mark a certain point on the rope. When the mark passes the starting point, press the stopwatch. When the time is up, the rope length is the distance from the starting point to the mark. However, because the length difference is small, a little inaccuracy in measurement or instability of the device will cause a large error. After continuous improvement of the measurement method, more accurate data were obtained. Come to us if you want to play with it. I can show you our model and have fun with it together. We can make more measurement and improve it more too. We are Group 5. Our model is the time in your mood, which can give you a time in your mood. Thanks for your listening. This situation, I'm not in a hurry. I want to be relaxed. So I use 2.5 sticks of the paper, and this time I want to have 30 seconds. So if I use 2.5 sticks of the paper and I want to have 30 seconds, I have to set the rope length for 10.5 centimeters long. Okay, let's see. It's about 30 seconds. This situation, I'm in a hurry, so I use 4 stacks of the paper. And I want to get 30 seconds in this situation. I want to get 30 seconds with a high frequency strike sound. And if you see our data, we have to set for 11.2 centimeters rope length. Okay, let's see. It's about 30 seconds.